thank you very much for coming back again. This is part 2 of From Arithmetic to Algebra. The goal of this particular series is to bridge your knowledge gap from arithmetic and then algebra, and then help you understand the new concepts that you need to know. The first thing we're going to talk about in this video is coefficient, and then we're going to talk about, first of all, numeric coefficient, and then we also talk about literal coefficient. Right, it's very simple. Let's look at an example. So if I have a term 5 is a number, right? Whenever you see literals in mathematics, we are referring to alphabets, either a single alphabet or combination of alphabets. They are literals. So let's look at expressions. Expressions actually bring together terms, okay? And so we're going to have, let's say, an expression like 8y plus 5. Now in this expression there are two terms. There is the 8y term and there is a 5 term here. Now in this 8y term there is a numeric coefficient, let's call it NC, and there is a literal coefficient, let's call it LC. Now let's look at some examples. If I have x, y, I have 3y over 7. I have 3ab over 5c. Let's look at the numeric. There is no number here, meaning that there is 1 here, right? So the numeric coefficient and then the literal coefficient. The numeric coefficient here is 1, and then the literal coefficient here is xy, combination of literals. The numeric coefficient here is 3 over 7, and then the literal coefficient is y. Here, guess what the numeric coefficient is? That will be 3 over 5, and then the numeric coefficient is a b over c. You understand? So now you understand what we mean by numeric coefficient. Now these things are very important because we are going to talk about like and unlike terms, okay? And so before we do that, you have to know some of these things. Okay, let's continue. The next thing we're going to talk about is terms. Usually in algebra you're going to have expressions that are of many terms. So look at it this way: terms are separated by either a plus or a minus, okay? And to know the number of terms, just count the number of plus or minus, and then add one to it. Let's look at some examples. So 8 a b c. Now this does not have any plus or minus, so it is 0, right? 0 plus 1 is 1 term, so this is 1 term. This is only 1 term expression, right? Let's look at this, and that term is 8abc. Now let's look at it. 8 plus a plus bc. Now here, how many pluses do we have? Plus or minus? We have 1 here, we have 2. So we add extra 1 to it, that will be 3. So it means there are 3 terms here, and those terms are 8 a and then bc. Let's do 2 more. 3b plus c plus d. This is also 3 terms. I'm sure you found that. And the terms are 3b, c, and then d. Let's see, if I have 3 plus b, c, d, there's only 1 plus sign here. That means that we're going to have 2 terms, and that is going to be 3 and then b, c, d. You got it? 2 terms. Let me give you one that is a little difficult. If I have 4x plus y plus c. Now again, it's the same thing. How many pluses can you see? I'm sure you can see this. You can see that, right? So that is 2 plus 1. That was going to be 3 terms. And those terms are 4x, 4y, and then C. You understand? So it is pretty very simple. So again, terms are separated by a plus or a minus. If you want to know the number of terms in an expression, just count the number of plus and minus and add 1 to it, and then you can always find that. It's a very simple approach. Now, having known the number of terms, we have to talk about what we refer to as like terms. So like and then unlike terms. Now you know how terms are. So how do you know if two terms are alike or unlike? Because if two terms are alike, it means that they can be added or they can be subtracted, and it's very important that we know. A lot of students do have problem with that, trying to identify like and then unlike terms, and that is why we did coefficient, right? There is just one simple rule you need to know. For a term to be like, the literal coefficient, right, should be the same. And we already mentioned the literal coefficient. We said that if I have 8a, the literal coefficient here is a. If I have 10 STRD, the literal coefficient here is STRD. We already did that, right? Cool. So let's look at some examples. Again, don't forget, for two terms to be like terms, the literal coefficient should be the same. So let's look at some examples. So I have 6x and x. This is 1. 2 here. I have 8x and 7y. 3 here. I have 8a squared and 2a squared. Let's look at, I have 5rx squared and 2r squared s, right? Let's look at the last one. If I have 5rx squared and 2rx squared, let's look at it. Now the numeric coefficient here is 6, the numeric coefficient here is 1, but that is not what we are interested in. We are interested in the literal coefficient, which here it is x and that is x, so that is like. Here the literal coefficient is a squared. Here the literal coefficient is also a squared, that is like. Here the literal coefficient is rx squared. The literal coefficient here is rx squared, that is like. Let's look here. The literal coefficient here is x. The literal coefficient here is y, that is unlike. The literal coefficient here is srx squared, but the literal coefficient r squared x, they are different. R x squared and then r squared x, they are different, okay? And so here is unlike. So that's exactly what you do. Now what is the importance of this? When you have like terms, you can add or subtract them. So this term here, if I put a plus here, 6x plus x will give you 7x. 8a squared plus 2a squared will give you, you just add the numerical coefficient and that will give you 10a squared. Here will give you 7rx squared. But unlike terms can never be added or subtracted. So that is why it is very important. Let's just do this example and then let's bring this to a close. So let's see, for instance, if I have 18a plus 12a minus 10, 6b plus 20c plus 2b minus c. So just these two should be okay. Let me just pause for a minute and see if you can identify like terms. So see, here you have a, here you have a, so you can just combine their coefficients, numerical coefficient, and that will give 18 plus will give you 30, so that will give you 30a minus 10 and then 30a. There are no common literal coefficients, so you cannot add them. So here you have b, here you have b, so you can just combine their numerical coefficient. 6 plus 2 will give you 8, so that will be 8b. Here you have c and here you have c, so you can just subtract. So this, so you have 20 minus 1, that will give you 19, so plus 19c. So you see what I mean? So very simple as that. Thank you very much for watching this video. I really appreciate you.